So the second part of the lesson today is to find, to just talk about geometric sequences. So a geometric sequence occurs when you have a common ratio between consecutive terms. So that means you either multiply or divide the value to get the next value, and you have to have the same number that you're multiplying or dividing by. So to find a term that's further away in your sequence, you can use this geometric sequence formula, where let's say you wanted to find the 20th term, then n would be 20, so you'd say a sub n is equal to, or a sub 20 is equal to the first term, which is a sub n, or a sub 1, times the common ratio r to the n minus 1 power, and n is the number of terms. So this geometric sequences are exponential. And we already talked about arithmetic sequences, but and they are linear. So these are exponential, and then the arithmetic sequences are going to be linear. So that's one way that you can tell the difference between these sequences. Now, let's go down here and let's do a couple of examples. So the first example says to determine whether or not these sequences are geometric. If they are, find the common ratio, and then if that's the case that they are geometric, then you find the 15th term. So to do this, sometimes it's obvious. You can look at one number and see what you multiply by or divide by to get the next one. But in this case, it's not quite so obvious. So the easiest thing to do would be to take the second term, so in this case 115, and divide it by the first term. So when you take 115 and divide it by 23, you're going to get 5. So now you have to ensure that the next two terms also have that same common ratio. So you take 575 and you divide that by 115, and sure enough, you get 5. Then you got to see if the last two terms there have that same common ratio. So we're going to take 2875. We're going to divide that by 575, and you get 5. So in this case, r is equal to 5. So this is geometric. So to find the 15th term, we're going to use this sequence formula, or the geometric sequence formula. So the 15th term is going to be equal to the first term, which was 23, times our common ratio, which is 5, to the n minus 1 power. So in this case, it's 15 minus 1, or the 14th power. I'm going to go ahead and just cross that out and make that 14. So when you do this in your calculator, you're going to take 5 to the 14th power, then multiply that by 23. If you do that, you will end up with a big number, so it'll be 1.4 times 10 to the 11th power. Okay, notice on this, when you do this in your calculator, you're probably going to get something that you might get an E, or you might get an EE on your calculator, and that's going to show you that that's scientific notation, so that's where the 10 to the 11th comes. Now the next sequence, let's see if it in fact is arithmetic. So to do that, let's see if we can determine if it's got a common ratio. So the easiest ones to look at is if you look at these two values, and if you say, okay, what do I have to multiply 1 by to get to 1/9? And that's pretty easy. All you have to do is multiply 1 by 1/9. So in this case, if this is a geometric sequence, your common ratio would be 1/9. So let's look and see if that's true for some of these other values. So we'll take 27 and we'll divide it by 81. And if you do that and you reduce the fraction, you'll notice that 9 goes into both 27, or actually 27 goes into 81. So 27 goes into 81 3 times. So that reduces to 1/3. Now, since these values are not equal, that means there's no common ratio. So this guy is not geometric. So there is no common ratio, so it's not geometric. So we can't find the 15th term. All right, so the next example that we're going to do is finding the middle number between two values for a geometric sequence. So the way you do that is you use this equation right here. So you're going to find the geometric mean, you're going to take the product of the two numbers, so multiply the two numbers, take the square root of that product, and then add a plus or minus in front of it. So let's do this example. So we're going to get the geometric mean, we're going to take the product of the two numbers. So that means multiplication. So 17 times 425. You're going to take the square root of that, and then we're going to put plus or minus in front of that. And let's talk about that in a second. So if you calculate this number, you're going to get 85. I'm going to add the plus or minus to that because that's necessary to go in here. So what that means is if you take 17 and multiply it by 85, you're going to get 425. If you take 17 and multiply it by, oh, I'm sorry. This number right here is negative 85. That's not true what I said. To get the common ratio, you're going to take negative or positive or negative 85. It depends what you want it to be. Positive or negative 85, and you're going to divide that by 17. So when you do that, you get, I think you get 5, but that might be wrong. Yeah, so you get 5. So what that means is that this, you'd get positive or negative 5. So you could take 17, multiply it by positive 5, you're going to get positive 85, and then multiply that by 5, you get 425. Or you could multiply 17 by negative 5 and get negative 85, multiply that by negative 5, and you're going to get positive 425. So you can see how you can have either positive or negative values there. Okay, now the last examples we're going to do, you need to look at these sequences, and first you got to determine, okay, is it arithmetic, is it geometric, or is it neither? Once you've got that figured out, then you can use the formula or not to figure out if whatever the 19th term is of this sequence. So let's start with this first one. So let's check and see if it's arithmetic. So what that would mean is you would have to take 11 and add something to it to get to 33. So if you add 12 to that, you're going to get 33. But if you add 12 to 33, you won't get 99. So it's not arithmetic. So let's see if it's geometric. So if it's geometric, if you take 33 and divide it by 11, you're going to get 3. So if I multiply 11 by 3, I get 33. If I multiply 33 by 3, I get 99. 99 times 3 is 297. So this is a geometric sequence. So that means that this value of 3 is r. So r is equal to 3. So in order to find the 19th term, which is what this is asking us to do, we're going to take and use the geometric sequence formula. So a sub 1 times r to the 19th minus 1. Okay, so that's going to be, if you stick in numbers, it's going to be, your first term is 11 times 3 to the 18th power. So when you calculate that out, you're going to get a really big number. So a sub 19 is going to be equal to 4 trillion, I think it is, 261 billion, 625 million, and 379. Oh, I didn't do that right, did I? So it's 4,261,625,379. Okay, and then the last one, first you need to determine, okay, is it arithmetic, is it geometric, or neither? So let's see if we can figure that out. So if you look at that, you probably can see that your common difference between each of these values is -3. So you're subtracting 3. So to get the 19th term, what that means is this is arithmetic. So to get the 19th term, you're going to take the first term plus n minus 1, so 19 minus 1, times whatever the common difference is, and we've just figured out that the common difference is -3. So the first term is 20, the 19 minus 1 is 18, the common difference is -3. So if you figure out what that value is, your 19th value for this arithmetic sequence is 34. In the next lesson, we'll talk about arithmetic and geometric sequences.